Hello everyone, very good morning and welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Yes, Chandrasekhar, Sai Shruti, very good morning. Now we are going to discuss what? Inverting operational amplifier, ideal condition, practical condition and important numericals, right? And that is the important topic for a GATE exam, and this is for electronics, electrical and instrumentation branch. Okay, let me know that sound quality, picture quality, everything is fine. Yes, please. Chaliye, everything is fine now. Yes, thank you Chandrasekhar. Now this is a inverting operational amplifier. In first session I have discussed how to get the command over analog, right? And in second session I have given you the basic idea of the operational amplifier, right? Each and every characteristics of the operational amplifier. Now we will deal with what? Inverting operational amplifier, right? And what about the applications of inverting operational amplifier? Now that is my introduction. Myself Sanjay Rathi, 21 plus years of teaching experience in the field of competitive exams, ECE, GATE and PSU. So please try to use my experience, and you can ask your doubts also, right, related to what? Inverting and application of inverting operational amplifier. And these are my ranks in engineering services exam 2005 AIR 16 and 2008 AIR 21. Okay, then Dreamer, very good morning everyone, very good morning. Now that is information for you. 90% scholarship on a GATE preparation program, 12th June 2022 at 11 AM. Please note this time, and that is golden opportunity for you. Okay, give this test. And this is a complete analog series, electrical, electronics and instrumentation branch from 6th to 14th. Here we are going to discuss basic idea about the operational amplifier, about inverting op-amp, non-inverting, differential amplifier, voltage to current converter and important 11 questions, okay, on 14th June. Now in last class already I have discussed. If you have any doubts and then anything, then you can ask me, and then please share the link of this session, okay, and like the session, subscribe our channel. Now if you have any specific doubt, then please post your comments in comments box. Now in first session we have discussed what is operational amplifier, why it is called operational amplifier, and basically it is a voltage control voltage source. What about the internal diagram, input resistance, output resistance, gain bandwidth product, bandwidth, why we are giving the negative feedback, why it is a multi-stage amplifier, each and everything we have discussed in first session. If you have any doubts, then watch my previous session on basics of operational amplifier. Now that is the point. Already I have discussed. Now these are the characteristics of the operational amplifier. That is the internal diagram of the operational amplifier. Now today we are going to discuss what? Inverting operational amplifier, right? Inverting operational amplifier. Now what is the inverting operational amplifier, right? And what about the feedback? Everyone give me the in comments box. Here it is a positive feedback or negative feedback. Here we are connecting the RF. This is connected here. That is the symbol for the operational amplifier. This is called non-inverting terminal, and that is called inverting terminal. Here the negative feedback is connected, and that is called inverting operational amplifier, right? Yes, very good morning Sapna. Now this diagram, right? What about the questions? First of all, what is the gain of the system under ideal condition and practical condition? What about the input resistance under ideal condition and practical condition, right? And what about the applications of this? Yes, in this circuit the feedback is what? Negative feedback. and there are four types of feedback mechanism. There are four types of feedback mechanism. That is what: voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So in case of operational amplifier, we are having the two types of feedback. That is what: voltage series feedback and voltage shunt feedback. In both the cases, we are sampling the voltage. So here it is a voltage, here it is connected the node, and that is the case of voltage shunt feedback. So remember this: in case of inverting operational amplifier, there is a voltage shunt feedback. There may be a question on MSQ. We will solve one question. That is what MSQ, multiple select question. The feedback mechanism in inverting operational amplifier is voltage shunt feedback. Remember that point. Okay. Second thing, how we are going to find again ideal and practical condition. Under ideal condition, normally we are using what? Virtual short concept. That is the actually, this is the approximate, 1 minute. Watch this diagram. This is RF, this is R1, this is VS, and this is right. Now try to understand. This is a inverting operational amplifier. Just everyone have idea about that. We are using the virtual short concept. What is the meaning of the virtual short concept? This is the VP, this is the VN, this is called positive terminal voltage, that is called negative terminal voltage. For ideal operational amplifier, this gain is infinite, and that's why VP is equal to VN, or we can say VN is equal to VP is equal to 0. This is called virtual ground process. Virtual ground process, right? Now when we are solving, or always remember, the current enter into the operational amplifier is 0, I1 and I2 are 0, then we can apply the KCL at this point. Incoming is equal to outgoing. Directly you can say 0 minus Vs by R1, 0 minus Vs by R1. I am applying the KCL, remember that, because the current enter into the operational amplifier is 0. Why? Because the input resistance is infinite for ideal op-amp. The current enter into is equal to 0. Ri is infinite. Now this I1, this I2 is 0. Then we can apply the KCL at this point. That is a very simple approach for any diagram. 0 minus Vs by R1, 0 minus V0 by RF. 0 minus V0 by RF. Simple KCL. First, virtual short concept. Second, remember I1 is equal to I2 is equal to 0. And third, apply the KCL, and that is the value. And you are going to get the gain V0 by Vs is equal to minus Rf by R1. Very simple approach to solve this question. Okay. So that is the minus Rf by R1. That is the gain for inverting op-amp under ideal condition. Second thing, what is the input resistance seen by the R1, seen by this Vs? Always remember the input resistance seen by Vs, because this point is 0, the current given by this is I. Let this is the I current. When we are going to find the input resistance for any diagram, then simple R in, what is the value of the voltage, what is the current given by that? Simple logic. What is the value of the battery and what is the current given by that battery? Vs upon I will give you the input resistance. So in this case, since this voltage is 0, what is the current given by this? Vs minus 0 by R1. Here the I will become Vs by R1. Put here Vs cancel, and you will get R in is equal to what? R1. R in is equal to R1. That is the simple logic for this question, particular question. Rs is equal to what? R1. Now dear students, ready to solve some questions? Yes, Sapna, your answer is correct. That is the input resistance is R1 and the gain is what? Minus Rf by R1. Phase shift is that is what is the phase shift? 180 degree, because here we are getting the negative sign. Phase shift is equal to 180 degree. Now already I have given one question. Give me the answer for that particular question. Watch this question on inverting operational amplifier. This was the question. This Vs is equal to 1 volt. This is 1 kilo ohm. This is 10 kilo ohm. And this is 10 kilo ohm. This was the V0. What is the value of I, everyone? Ideal operational amplifier. Ideal operational amplifier. What is the value of I? Now question on inverting operational amplifier. Just which type of question they may ask, we will discuss one by one. Yes, tell me what is the answer for this question. Okay, then this is the RF, that is the R1, this is the RL, V0. Now here it is a negative feedback, right? We have to find the value of the I. Always remember one thing, the input resistance of the op-amp is 0. That's why this current and that current is 0. Current enter into the operational amplifier is 0. Second thing, since AV is infinite, therefore virtual short concept is valid. V1 is equal to Vn is equal to 0. Voltage at these 2 points are 0. Vp is equal to Vn is equal to what? 0. Right, simple. Now how to find the current? Very simple question, that is given 2 milliampere. So first of all, remember that what is the voltage at this point? This is the 0, right? The current through this branch will pass through that 10 kilo ohm resistor. Same current, because current enter into the op-amp is 0. So what will be the current here? Vs minus 0 by R1, that is nothing but Vs by R1. That is the let I1, sorry, because this is the I, let this is the I1. So I1 is equal to Vs by R1. Same current will pass through the RF. This is the I1. Now current through RL, let this is the IL. Let this is IL, load current. What is the load current? V0 by RL. So what is the I? This is the incoming current, that is the incoming current, and that is the outgoing current. Sum of the incoming current is equal to what? Outgoing current. Sum of the, this is the incoming, that is the incoming, is equal to outgoing current, and then we can find the I is equal to what? IL minus I1. IL minus I1. Now I1 is the Vs by R1. What is the IL? V0 by RL. So what is the V0 here? V0 is nothing but minus Rf by R1 into Vs. Already we have the gain, minus 10 by 1 into Vs, that is the 1, minus 10 volt. Minus 10 volt. Remember that that is the minus 10 volt is the value of the V0, because it is a inverting operational amplifier. Gain is minus Rf by R1. Now once you have the minus V0, then you can find the IL. What will be the I? V0 upon RL, general formula, V0 minus 0, because this is the ground. Let this is the IL, V0 minus 0 by RL, minus I1. What is the I1? Vs by R1. What is the V0? Minus 10 divided by RL. This is the 10. Minus 10 divided by 10. Minus Vs, 1 divided by 1. And what is this? Minus 2 milliampere. Minus 2 milliampere is the answer, right? With polarity. Always remember, we have to give the answer with polarity, because I have given the direction here, and that's why this is the negative value. Actually it is a negative value, minus 2 milliampere. That is the Important answer for this particular question. Okay. Now, if suppose in this part, this is the numerical, 2 marks numerical in GATE exam or other competitive exams, but in interview they will ask, or other type of questions. Suppose I am changing the value of RL. Suppose this RL is not fixed. If this RL is variable, then what will happen? What is the answer? For example, I am reducing the RL to 1 kilo ohm. If suppose I am reducing the RL to 1 kilo ohm, I am reducing the RL to 1 kilo ohm. What about this current? Tell me. If in place of 10 kilo ohm, I am using RL is equal to 1 kilo ohm. Just variable. 10 times. I am reducing the RL 10 times. What about this current? This will remain same, Vs by R1. This will remain same. This V0 will remain same. Why V0 will remain same? Because it is independent of RL. So V0 will remain same, minus Rf by R1 Vs, that is the minus 10 volt. So what is the change here? Only change in what? IL. Only change in IL. So, and that's why I have given you the general answer, general formula. Remove this. What is the value of I now? This V0 will change, V0 will remain same, minus 10. RL is changed here. Vs is 1 volt, R1 is 1 volt, it will remain same, that is minus 11 milliampere. Minus 11 milliampere will be the answer. If I am changing the value of RL, that will be the answer, minus 11 milliampere. Right? Now, what is the concept of the operational amplifier? Very, very simple. We are changing the load, V0 will remain same. The current given by this battery will remain same, means there is no loading effect. There is no loading effect. We are changing the load, the gain of the system will remain same, output voltage will remain same, and the input resistance seen by the Vs will remain same. The current given by the Vs will, that is the source voltage, will remain same. Okay, and that is the logic of this operational amplifier concept, loading effect. Some students are confused with the loading effect. Loading effect means what? We are changing the load, and when we are changing the load, the current will increase, but V0 will not affected, and the current given by Vs will not affected, gain of the system will not affected. I think that concept is clear, everyone. So this is a very, very important question. Remember, in GATE exam directly give the answer minus 11 ampere, and that is the formula, general formula. We are simply using the KCL. We are using the KCL at 2 points, at this is the point and that is the point. Now, another question, another very, very important question. Yesterday one student asked that doubt, what should be the answer for this question? Right, that is the general one. Now let that is the MSQ. It is visible to you, everyone? यार ये ज़रा please share the link of this session, because I want to take some I want to give idea about questions based on inverting operational amplifier, question based on what non-inverting operational amplifier, what about the silly mistakes, right? And how to solve the questions, what is the use of the virtual short concept, right? And if suppose we have to find the exact analysis, then what will be the approach, and so on. Okay. Yes. If suppose we are giving the equivalent circuit, then we have to, in a particular numerical, if ideal op-amp is given, then what about the R0? R0 is what? 0. Ri is what? Infinite. If suppose everything is given, then we have to consider the equivalent diagram. Then that question will be based on what? Network, Sapna. Network. We will, so I will give you the one diagram. Okay, but that is the question. Assuming the operational amplifier to be ideal, what is the gain? Input resistance seen by the Vin. This is the Vin is connected here. Feedback mechanism. This is the MSQ. This is MSQ. And it is a standard diagram. Now, there are two or 3 different approach how to solve this question. Watch this. And what is the advantage of this diagram? Right. Now, this is the 1 kilo ohm resistor. This is the V in, that is the V out. First of all, how to get the gain, and then I will give you some silly mistakes, right? That is 10 kilo ohm, 1 kilo ohm, 10 kilo ohm, 1 kilo ohm. Virtual short concept is valid, that is the Vp is equal to Vn, because there is a negative feedback. Always remember, if there is a negative feedback, this is called virtual ground process. It is valid here since the gain is infinite. Always remember, this is the I1, that is the I2, it will be 0 because the input resistance is infinite. Now, you can apply the KCL at this point, or you can apply the KCL at this point, and you are going to get the value of the V0 by Vin. Very, very simple, right? Then, first of all, in this particular question, this is a very important diagram here. Vin minus Vn minus Vin, 0 minus Vin, 0 minus Vin divided by 1 kilo ohm plus 0 minus Vx divided by 10 kilo ohm is equal to 0. From this you are going to get Vx is equal to minus 10 Vin. Vx is equal to minus 10 Vin. Okay, and then what? But we want V0 to write down the KCL at Vx. To Vx minus 0, this is the Vx minus 0 by 10 plus Vx minus 0 by 1, Vx minus 0 by 1 plus Vx minus V0 by 10 is equal to 0. You can take 10 as LCM. You are going to get Vx plus 10 Vx plus Vx minus V0 upon 10 is equal to 0. Now V0 is equal to 12 times of Vx. From this, only 2 KCL in operational amplifier, remember that. So Manvendra, very good morning everyone. Now, since Vx is equal to 10 times of Vin, V0 will become minus 120 times of Vin. What is the V0 by Vin? Minus 120. Minus 120. Right? And that is the gain of this system. Minus 120. Very high gain. Right? This is the simple logic. Minus 120. And it is an inverting operational amplifier. And that's why the feedback mechanism is what? Voltage shunt feedback. So which answers are correct? The gain is minus 120. Feedback mechanism is voltage shunt feedback. That is also correct. Voltage shunt feedback. Input resistance seen by the Vin is infinite. Now, always remember what is the input resistance seen by the Vin. That is the input resistance. Already I have mentioned. This is the 0. This is the Vin. This is the R1. So what is the input resistance seen by the Vin? That is the Vin divided by the current given by that. Current given by this, this is the I. Vin by I is nothing but R1. So what is the input resistance? 1 kilo ohm. But what is given here? Infinite. And that's why that answer is wrong. Yes, notes will be available just after the class. I will upload the notes on my Telegram channel. Today definitely I will upload the this PDF of all this session on my Telegram channel, that is Electronics by Sanjay Rathi. So please join that channel, Electronics by Sanjay Rathi, right? And PDF, and you can also ask your doubts related to what op-amp, so that in next class I will cover those doubts. Okay, so that is one student asked me one doubts related to that diagram. Now I am going to explain that. So Rin is equal to R1. So that is wrong. So A and C is the answer for this question. and that is the MSQ. That is the MSQ. Now, that is the Manvendra, that is the doubt. What 10 kilo ohm or 1 kilo ohm we can take in parallel? Now I am going to give you the answer. This is the number of students have the same doubts. Sir, this is the 10 kilo ohm, this is the 1 kilo ohm, this is the 10 kilo ohm, this is the 1 kilo ohm. Now, number of students have this doubt. Now, please focus, everyone, please focus on the board. Sapna, when we are applying the Miller's theorem, when this is the practical condition is given, for example, AV is what? Finite value. Here we are using the AV infinite, and that's why the no need to use what? Miller's theorem. If suppose this is a practical operational amplifier, then we have to use the Miller's theorem. Okay, everyone. Now this is the virtual short concept. So Vp is equal to Vn is equal to what? 0. So Vp is equal to Vn is equal to what? 0. Now, number of students will use this approach. Since that is 0, since this term is 0, this term is 0, and that's why these two resistors are in parallel. According to some students will use this concept. And now I am going to explain why it is wrong. Why it is wrong. When this is ground, this is virtual ground. If suppose you are taking that, let these two are in parallel, then you will find the RF here. What is the RF here? This 10 kilo ohm and 1 kilo ohm are in parallel, and that 10 kilo ohm in series. Your RF will become 10 parallel with the 1 plus 10. Right? That is nothing but 10 divided by 11 plus 10. And this is nothing but 120 divided by 11. This will be the RF. Yes? We are taking this 10 kilo ohm and 1 kilo ohm in parallel because that is 0, and we are getting the RF 120 by 11. What will be the gain? V0 by Vin, that is nothing but minus RF by R1. Minus 120 divided by 11 divided by 1, and what will be the gain? Minus 120 divided by 11. Yes, Manvendra, you are asking this type of approach? Yes. That is wrong approach. Why? Just I'm going to explain you. This is the wrong approach. This is, we are taking this 1 kilo ohm and 10 kilo ohm are in parallel, and that is we are solving like this. But what is the problem with this question? The problem with this question is, here it is a virtual ground. Try to understand what is the parallel combination. There are two resistors, they are connected in parallel. Everyone give me the answer for this question. This is the 5 ohm, this is the 10 ohm, this is the 10 ohm. This is the 10 volt battery. Everyone give me the answer for the I, and what is the I1 and what is the I2. Right, very simple question, just I want to explain. I want to explain that. Why? These two 10 and 10 ohm are in parallel, and that's why we can calculate the equivalent resistor. When I am calculating the equivalent resistor, this will become 5 ohm. Okay, no problem. This is the 5 ohm. This is the 10 volt. What will be the current I? Now I can find the I. 10 divided by 5 plus 5, that is equal to 1 milliampere, 1 ampere. Now what will happen? This 1 ampere current will divide into branch, parallel branch. Let this is the I1, this is the I2. If this is the R1, if this is the R2, it will. Here we have to use, what? Current division rule. So according to current division rule, I1 is equal to I into R2 upon R1 plus R2. Since both the resistors are equal, it is half of that. Similarly, you can find the I2 is equal to R1 upon R1 plus R2 into I. 1 by 2. Is there any doubt? Okay, Sapna, right answer I1 1 milliampere, 1 by 2, 1 by 2. Everyone, please solve this question on your rough page. Now, 1 by 2 is the current. Here we are using the current division rule for parallel resistor. Yes. Here we are using the current division rule for parallel resistors, and that's why we can directly solve this question by using the KCL. We can directly apply the KCL here and we can find the value of the I1, I2 and I simply by writing the KCL, or we can calculate the R equivalent. So we have the different what approaches. We can directly apply the mesh analysis, nodal analysis, or we can find the R equivalent to find the current I. Now in this diagram, tell me what is the current here? I is nothing but V in by 1 kilo ohm. Let this is the R1, this is the R2, this is the R3, this is the R4. So what is the I here? V in by I. But this V in by I, that is not divided here. Same current is passing through this. V in by R1, sorry. V in by R1, this is the current. Same current will pass through this 10 kilo ohm resistor. It is not divided between R2 and R3. Not divided. So tell me, these two resistors are in parallel. Everyone. If these two from this node, if you are assuming that two resistors are in parallel, means this current should divide into R2 and R3. Should divide into R2 and R3 following what? Current division rule. But it is not applicable here, and that's why we can't consider R2 and R3 in parallel. R2 and R3 in what? Parallel. I think that concept is clear. Okay. Now third approach to solve this particular question, that is why I am giving you so much information about that particular question, because it is a inverting operational, it is based on inverting operational amplifier. Number of times we have the similar type of questions, and therefore this diagram is very important. So I think that is clear. Now second approach, let this is the ground, virtual ground process. Now I want to solve, I want to get the gain. Let that is the current I. That is the current I. Okay. Just I am giving you the another approach. This is the I. Now I can divide, because this is the ground, that is the ground, this is the node Vx. Now I can divide this current into what? Between 1 kilo ohm and 10 kilo ohm by using the current division rule. Let this is the I1. Now I can divide, that is the, I have changed the path from right to left. So what will be the I1? I1 is equal to I divided by 10 plus 1 into what? 1, because I want to get the current through the 10 kilo ohm. That will become I by 11. Now same current I1 will pass here, because the current enter into the operational amplifier is 0. So same current will pass through this I1. Okay, no problem. Now you voltage at this point is 0, so you can find the I1 in terms of V in. 0 minus V in is equal, 0 minus V in upon 1 is equal to I1. You can find I1 is equal to 0 minus V in upon 1 kilo ohm. That is nothing but minus V in. Okay. Now very simple. Write down the KVL from this point to this point. Write down the KVL from this point to up to this point only, because the voltage at this point is 0. When I am writing the KVL, V0 is equal to 10 times of I plus 10 times of I1. Okay, that is 0. Vn is equal to 0. V0 is equal to. Now what is the I? I is equal to 11 times of I1. From the equation number 1, we can write 10 into 11 times of I1 plus 10 I1. You are going to get the 120 times of I1, that is the V0. But what is the I1? I1 is equal to minus V, minus 120 V. What will be the gain? Minus 120. So that is the right approach. That is the right approach. So from left to right, we can't consider 10 kilo ohm and 1 kilo ohm in parallel. But from right to left, we can consider 1 kilo ohm and 10 kilo ohm in what? Parallel. We are not calculating the RF. We are giving you the different, I am giving you the different approach. This I will divide into 1 kilo ohm and 10 kilo ohm. The same current will pass through this, and then we can use the current division rule, and we are getting the same answer, that is what? Minus 120. Everyone, that approach is clear? That approach is clear, right? So this is a very simple method, method number 2, how to solve this particular question. So this is about the inverting operational amplifier, right? Watch this question carefully. No, that is the MSQ. Okay. This is the MSQ, new question. Tomorrow I will take same time 8 to 9 p.m. We will discuss similar type or questions on what non-inverting operational amplifier, right? First of all theory and then important numericals on non-inverting operational amplifier. Now watch this question. This is the MSQ. MSQ. The inverting op-amp shown in the figure has an open loop gain of 100. This is not an ideal operational amplifier. If it is not an ideal operational amplifier, then it is what? 100. The gain is given as 100. 100, when the gain is given as 100, means we have to use what? Exact analysis. And what is the exact analysis? Simply you can draw the equivalent circuit, right? What is the equivalent circuit of the operational amplifier, or you can solve, just I am giving you the idea, or directly for this particular question you can remember exact formula for the gain, that is the AVS is equal to minus AV beta upon 1 plus AV beta into RF by R1. That is the formula. Minus AV beta upon 1 plus AV beta into RF by R1. Remember that RF by R1, you have the idea, this is called RF. This is the RF, this is the R1, 10 kilo ohm, 1 kilo ohm. And the beta here, beta is given by R1 upon R1 plus RF. R1 upon R1 plus RF. In this particular question, this is the R1, this is the RF, (1 kilo ohm, 10 kilo ohm). This is the VS. Now you can find the value of the beta. 1 divided by 1 plus 10, that is the 1 by 11. And then AV, it is given in the question 100, AOL is the 100 is given, then we can write directly AVS is equal to minus 180 degree phase shift, minus sign, 100 into 1 by 11 upon 1 plus 100 into 1 by 11 into RF, 10 divided by 1. Now you can find the value here, okay, minus 100, that is 11 cancel, minus 1000 divided by 111. Please check this, 111, that will be the answer for this particular question. Minus 1000, so you are getting the answer, Sapna, yes, minus 9.009 means nearly equal to minus 9. Minus 9. Yes, so that answer is correct. That answer is correct. Now new students will simply give the answer, sir, answer for this question is RF by R1 minus RF by R1 minus 10 by 1, that is equal to minus 10. But here we are getting the minus 9, that is correct. This is what approximate analysis. When we are using the virtual short concept, that is called approximate analysis, we are assuming the ideal operational amplifier, and that result is what? Minus 10. That is called overestimated. Overestimated means actually the answer is minus 9, but we are calculating by approximation minus 10. So magnitude is overestimated, मतलब ज़्यादा निकाल रहे हो आप, it is a 10, minus 10. So overestimated value, actual answer is what? Minus 9. Remember that formula, this is very important one. What will be the value of the beta and so on. Now feedback mechanism is voltage series feedback, that is wrong. Feedback mechanism is voltage shunt feedback. Input resistance seen by the Vs is 1.1 kilo ohm. Now the student will give the answer, sir. In previous question you have mentioned that input resistance seen by this is 1 kilo ohm. V in is equal to 1 kilo ohm. This is the 1 kilo ohm. Now tell me, what about this answer? That is right or wrong? This is the input resistance is 1.1 kilo ohm. Everyone please tell me, this answer is right or wrong? Because it is a MSQ, you have to solve this type of questions. Inverting operational amplifier, already I have calculated the exact gain, -9. That feedback mechanism is voltage shunt feedback. And finally it is given error in approximated calculation will be 11%. Now this is input resistance seen by the Vs is 1.1 kilo ohm. In that case we have to apply Miller's theorem. What is the Miller's theorem? Just I am going to give you the idea about that. Simply, if you want to calculate the input resistance, that is not the 1 kilo ohm in this case. How to solve? Because we have to apply the exact analysis, means AOL 100, right? This RF is given as 10 kilo ohm. In that case, when I am applying the Miller's theorem, this is the R1, this RF upon 1 minus AV. This is called Miller's theorem. This resistor is divided into two parts, one at the input side, one at the output side. So what will be the at the input side? RF upon 1 minus AV. What will be at the output side? RF AV upon AV minus 1. We are simply dividing this feedback resistor between input and output, that is the RF upon 1 minus AV, RF AV upon AV minus 1. Now this is the voltage from this point to this point with respect to ground. This is the inverting voltage, because we are calculating the VI. Always remember, when I am taking the VI is equal to VN minus VP, negative terminal minus positive terminal voltage, then AV should be less than 0. In a particular question, the mod of AV is given as 100. Always remember, according to our requirement, we are using the AV. Suppose I am writing the VN minus VP, then the AV will become negative. If suppose I am writing the VP minus VN, then it will become positive. So in a previous derivation, we are using the AV is equal to 100, because during the derivation of this formula, I have used VI is equal to VP minus VN. So when I am using the VI is equal to VP minus VN, this is the VP, this is the VN, and this is called VI, VP minus VN, then you have to use the AV greater than 0, that is 100. But when I am applying the Miller's theorem, I am using the VI, this is the plus, that is the minus, this is the VP, this is the VN, that is the VP. In that case, you have to use the AV is equal to less than 0, means you have to use AV is equal to minus 100. Okay, remember that is the concept about the Miller's theorem. Apply the Miller's theorem, that is become RF upon 1 minus AV. Now everyone tell me, what is the input resistance seen by V? This is given as R1 plus RF upon 1 minus AV parallel with RI. Here we are having the input resistance Ri. So Ri parallel with RF upon 1 minus AV. Then this is the input resistance. These two are in parallel, and that is the R1. So R1 it is in series. That is the exact answer. In this particular numerical, Ri is not given. Ideal condition. Take Ri is equal to infinite. Infinite parallel with this RF upon 1 minus AV. R1 plus RF upon 1 minus AV. That will be the answer. Put the value here. This is the 1 kilo ohm plus 10 divided by 1 minus of minus 100. It is nearly equal to what? 1.1 kilo ohm. That will be the answer for this particular question. Okay, 1.1 kilo ohm. So when I am assuming the ideal op-amp, I am calculating only 1 kilo ohm. When I am doing the exact analysis, actually the value is what? More than that 1 kilo ohm, right? It means when I am using the approximate analysis, that value is underestimated. That value is underestimated. If suppose I am giving the value R in is equal to 1 kilo ohm, that is underestimated value. Why? Because exact value is more than that. It is underestimated. Input. This is also correct. This is also correct. Third thing asked on inverting operational amplifier, what is the error in approximate calculation? So my dear students, this is the exact formula. This is the exact formula, and RF by R1 is the approximate formula. Exact minus AV beta upon 1 plus AV beta into RF by R1. What is the approximate? Approximate gain is minus RF by R1, or this magnitude is overestimated. So what is the error? Approximate gain minus exact gain, magnitude of exact upon exact into 100%. Put all these value, RF by R1 is cancelled out, and you are going to get the 1 by AV beta. That is called error. That is called error in calculation when we are solving the question by using the approximate solution. So what is the AV beta? Error is given by 1 upon AV is given as 100. Already we have calculated 1 by 11 into 100%. Beta, already we have calculated the beta, that is equal to 1 by 11. AV is given as 100, and the gain is, what is the error? 11% error. 11%, right? If suppose we are doing the approximate analysis, that what will be the mistake? 11%, total 11% the error. Okay, so that is the just general formula. Remember that 1 by AV beta into 100%, and you can find the error 11%. This is also correct. Now everyone tell me, you are getting idea which type of question they may ask. We can make MSQ on inverting op-amp, MSQ on non-inverting op-amp. Some students are simply having the idea that okay sir, minus RF by R1, we will solve that particular question, no need to get the command over that. We can design extraordinary questions on what inverting and non-inverting op-amp only. We can change, right? Sometimes in electrical branch, watch the previous year question from the electrical branch, number of questions, highly conceptual questions from what inverting and non-inverting operational amplifier. So one by one you have to get the command over, because sometimes we are assuming that these topics are easy. According to me, these all topics are what? Highly conceptual. Sometimes we are getting the very easy question, and sometimes we are getting very conceptual questions. Please work on concept so that you will be able to solve this type of questions. Now, when everything is given, always remember, suppose just I am giving you one idea about the exact analysis now. Suppose everything is given, then R0 is given, R1 is given, and so on. Just watch this question, last one. For operational amplifier, that this is the R1, this is the Vs, this is the V0. For example, R in is given 1, Ri of the operational amplifier is given as 1 kilo ohm, 10 kilo ohm for let. R0 is also given as 100 ohm. Okay, RL, here RL is connected. This is given as 1 kilo ohm. Okay, RF is given as 10 kilo ohm. Let this is the 1 kilo ohm. RI is given, R0 is given, RL is given here, AV is also given here. That AV is 100. Right. Magnitude of this AV is 100. Then how to solve this question? how to solve this particular question. Always make the internal diagram, because it is basically a voltage amplifier. Make the equivalent diagram of the voltage amplifier. What is the equivalent diagram? This is the RI. This is AVVI. And this is R0. Remember that. Now, since the input is connected, remember, input is connected to inverting terminal. Input is connected to inverting terminal. You have to take precaution. If you are taking the AV greater than 0, if you are going to take the AV greater than 0, but the phase shift is 180 degree, you have to put the sign minus plus. This is the minus, this is the plus, and you have to take AV equal to 100. But if suppose you are going to take AV less than 100, less than 0, negative, to change the polarity. This is the plus, that is the minus. So normal approach is what? Because of 180 degree phase shift, this is the minus, that is the plus, AV is greater than 0, that is 100. Now that is the R0. Now try to understand. This is the terminal that is connected to ground. Okay, no problem. This is connected to ground. What is the voltage from this point to this point? Like this is the VI. Because of 180 degree condition already we have considered. Now here this R1 is connected. This is the VS is connected. Now here RL is connected. From this is the output, this is the RL is connected. We are taking the output here. Now one extra resistance is connected here. What is this? RF. From this point to that point. RF is connected here. Now everyone tell me, now this is the question from analog or network? Analog or network, everyone? Now if suppose I want to calculate the V0 by Vs gain, use the concept of what network V0 by Vs, how to find the V0 by Vs. Now when I am giving the let, this is the current here I, this current is divided into two parts, let this is the II, so it will become I minus II. Right? What is the VI? VI is nothing but II into what? RI, and then in this way we can find the gain. AV is given as 100, because we are changing the polarity. This is the minus, this is the plus, means we have considered what 180 degree phase shift, and you have to use the minus, we have to use what 100 value, 100, not minus 100, because we have considered minus plus. Very simple approach. Okay, ban jayega. That is the case how to solve this particular question. Okay, yes, now we can use the nodal analysis or any other approach. That is the question on based on what? Two-port network. Try to solve this question and give me the answer. What will be the V0 by Vs? Everyone, that is the assignment. V0 by Vs, find. Already I have given each and everything. This is RL, RF, RN, RI, R0 is given, RL is given, everything is given. Now find the value of V0 by Vs. What is the input resistance seen by the Vs? R in. You have to find the R in. That is the Vs by I. Vs by I. Find the input resistance R in. And last but not the least, what is the resistance at this point? That is called Thevenin's resistance. R naught des, right? What is the value of the Thevenin's resistance or R naught des? What is the output resistance seen by the RL? Because already one RF is connected here. To solve this question, we can use the Miller's theorem, or directly we can apply the KCL or KVL. We can find the value. Always remember, when we are going to find the Thevenin's resistance, you have to make this Vs is equal to 0, because there is a dependent source. Make RL is equal to infinite, and you have to connect extra battery V by I. Now if you have idea about that, okay. If you want to get the idea about that Thevenin's, already number of sessions are available. Second thing, I am going to take one important sessions on Thevenin's theorem and what resonance, first order transient on app, install BYJU'S Exam Prep app. तो up to this point any doubt यार? लेकिन आप लोगों ने थोड़ा सा आप इससे रेगुलर रहिएगा, सबको बोलिएगा कि शेयर करें इसे. Please share the link of this session, like the session, first of all like the session, right, and post your doubts also, right. Already one student have given me the doubts related to that particular question, why we are not connecting it in parallel, what is the virtual short concept. One student asked that, sir, please draw the equivalent diagram related to what R0. So that is the equivalent diagram, very simple, we can use. Normally students are making mistake here, they are not considering the 180-degree phase shift, and that's why we are getting the wrong answer for this particular question. Okay then, to hope so enjoy the session. Yeah, tomorrow we will discuss non-inverting operational amplifier. So this is the assignment for you. Already I have given one assignment, that is the another assignment. I will upload the PDF on my Telegram channel, that is Electronics by Sanjay Rathi. Try to solve that question. This is very easy question. This is the 1 microampere current here, directly current enter here, 1 microampere, 1 kilo ohm resistor here. This is a inverting operational amplifier. Now the output of this enter into this, and that is a non-inverting op-amp. Because the input is given to positive, here RF and R1 is connected here, again the feedback is negative, what will be the output? So this is the question based on inverting and non-inverting, cascading of inverting and non-inverting op-amp. So assignment number 2, try to solve this. Tomorrow I will discuss. And then already we have solved that particular question. This is a use of what? Virtual short and virtual ground process. Wait, I'm going to give another question. Yes, this one. If the value of the resistance R in the following figure is increased by 50%, the voltage gain of the amplifier shown in the figure. What is the role of the R? Why we are connecting the R in particular diagram? Again, that is the question based on what? Inverting op-amp. But what is the use of that R? Right? Use of this R. Normally in instrumentation branch, they will ask, what is the effect of input bias current and how we can reduce the effect of input bias current. This is the, we are connecting the R to reduce the effect of input bias current. So what is the answer for a particular question? What is the use of the R and what should be the value of the R? Each and everything we will discuss. Assignment number 3. Right? And I will give you the idea what is the effect, what is the meaning of the input bias current, input offset current, input offset voltage, output offset voltage. So this is all about the session. Please like the session, subscribe our channel. Thank you for attending the session. You are on BYJU'S Exam Prep, the most comprehensive app for all exams. Thank you and good day. Sir, we get same answer from both the approach, sir, that exact and equivalent circuit. Yes. Exact means what? Exact means what? We in a particular exact question, Sapna, what is given? R0 is not given, Ri is not given. So we are considering the R0 is equal to what? 0, Ri is equal to infinite, and that's why we are getting the answer. When R0 is also given, Ri is also given, each and everything is given, we have only one approach, that we have to draw the equivalent circuit. Finished? Chandrasekhar, sir, today there is no class in our schedule. Is there any changes? No, I have no idea about that. You are talking about which classes? Paid classes? I have no idea about that. I have to check that. Okay. I think you have classes. If you are paid students, then we have classes. I have classes from 6 to 8 p.m. Okay then. So you are on BYJU'S Exam Prep. Thank you for attending the session. Thank you very much.